Advanced database, easy oh. Oh, okay. Any student have taken advanced database? Easy ah. Okay, everyone can say okay. So I don't know lah. I guess only okay. So now, doesn't matter lah. Okay, I don't understand one. Some of you is very busy with your assignment and your project ah. Okay. Now, for reverse engineering, okay, we come to the topic of reverse engineering techniques. Okay, definitely when we perform reverse engineering, we are going to create the system representation in different level. Okay, from the code level, maybe from the design level, or from the specification level. Okay, so one of the techniques using here is the visualization. Okay, be careful a bit. This one is a bit confusing also because the terms used here. So visualization, what is mean by that? Okay, this technique actually is using some visual diagram, okay, to help us in understanding, okay, the system, the existing system structure, okay. So, and look at here, okay. So the efficiency of code analysis and design recovery approach is influenced by the visual representation of a system. Definitely lah, because this representation, okay, is very important one. If you create it wrongly, okay, then will lead you to another direction or to the wrong direction or wrong understanding already. So therefore, in visualization, there are two terms here: visualizations with the S and representations. Okay, these are the notions that used to represent the data in a graphical manner. Understand? Other 2D, 3D, or virtual reality. Understand? Okay. So what is meant by visualizations? Got S1 now. Okay. So representation actually is the graph or media or graphics that used to represent a single component. Okay, a single component. However, visualizations okay, is a configuration that means a graphical configuration that used to represent a group or more than one components understand, in higher level. Okay, look at here. A configuration of an interrelated set of individual representation means that visualization consists of more than one representations. Okay, so this is what I mean. Actually, it's the same thing lah. One is used to represent only one component. One is used to in high level shows the connection between components. So some sort like that lah. Understand? Okay, the system representation between components. This is inter. Okay, this is intra. Okay, now when we want to design the visualization, okay, using visualizations when we creating the graphic or even though the virtual reality 3D, 2D graphic okay. So what are the key attributes, okay, to evaluate this kind of representation? You can see that the black color word okay, is the key attribute, and then this is the explanation, okay. So individuality, okay, means that different component even type of component may use different representation style or visual style okay. Distinctive appearance means that okay, your graphic representation should be able to distinct among the component. Understand? Okay, when I look at this graphic, okay, this is the represent what kind of component is it? High information content, high information content here doesn't means that okay, you put a lot of information inside, means it's sufficient okay. So a summary of the corresponding component types information. Understand? High content information content. But however, if you put too many information inside, will lead to the complexity of the representation. Okay, therefore maybe you can if too many information you have to involve in one what we call the representation, maybe you can separate into different level okay, like our design separate into different level of design, understand, or separate into different level of representation. So each level of representation you may have your appropriate number of information there. Okay, low visual complexity, yes, don't make your graphic okay representation become too attractive, understand, okay, too many colors and too many lines, whatever things okay, make it okay in an appropriate level of complexity. Scalability of visual complexity allow your graphical representation should allow remove adding, okay, of new item inside. Understand? So this one same thing, flexibility of integration into visualizations. Okay, allow you to, how to say, perform some motion locate the position okay, color, size okay. So to represent those information, understand? Okay, different color, different type of information. Okay, angular velocity maybe is the degree of your turning changing the speed okay. So these are the flexibility for integration. Suitability for automation definitely okay, facilitate automation, okay, facilitate automation, okay, in generating the system representation or visualization. Requirement for designing a visualization. Actually, it's more or less the same with this one. This is the key attribute in evaluating and creating representation. This one is to designing a visualization, almost the same okay, the point. Simple navigation, okay, allow simple navigation of items in your visualization or your system representation. High information content provides sufficient info, not too many or not too less, based on the degree of abstraction. Low visual complexity should not be too complex, okay, until very difficult to understand the system structure from the graphics, okay. Different level of details, as we said that, okay, you need to shows the visualization or representation in different level of details. Abstract, high level to lower level means that maybe abstract to detail. Understand? Resilient to change means that flexibility means that allow changes. When these changes should not bring a major problem to your representation. Okay? Continue. I need to be slower a bit okay, otherwise we can finish within half an hour. Okay. Time control this is called, okay. Now okay, then continue requirement for designing a visualization effective visual metaphor you may need to use a metaphor, okay, to indicate, help you in better understanding. Friendly user interface for your graphic. Integration with other information sources. Let's say this is what we call similar to this one integration with other information sources is like this one okay. This one flexibility for integration, okay, almost similar one, okay. Okay, for example, okay, a shape that represents a module should be able to link to the code of the module. Understand? Okay, when you double click on the certain shape in the item, then maybe he can directly link to the related code or maybe related high level representation or lower level representation. Okay, so good use of interaction. Provide different views to understand the representation as you do your SDA. Okay, according to the Cartan's 4+1 view. What are the Cartan's 4+1 view? Logical view, process view, deployment view, development view, and the +1 is the scenario view, isn't it? Use case, okay? Hopefully you still can recall. Okay. You may provide different view, okay, so that maybe from different perspective okay, to present your representation, system representation. Definitely suitable for automatic to generate certain graphical representation or system representation. Okay. Now, we come to this one. Definitely, when we want to do maintenance or reverse engineering, sometimes we may need to use some metric to help us. Okay. Because this is a screenshot, so maybe I make it bigger. It's easy for you to read. Now, these are some of the metric showing here. Lines of code, I guess this one you know already okay, what is mean lines? How many lines in your system? But in your software testing, they say KLOC, right? Isn't it same thing? KLOC means 1,000 lines of code. Okay. So global variable GV, okay, the number of global variable you are using. Psychromatic complexity, This one is showing the number of linear independent path. Okay. Used to calculate the number of independent path. Okay, when you do the basis path testing. Read coupling. Okay, refer to the global variable read by a program unit. Number of variables read by one unit. Write coupling, the number of global variable update or write by a program unit. Address coupling, same thing, just that the address okay, the variable address okay, that are extracted by a program unit but do not involve read and write coupling. Okay, just extract only the address, okay, but does not inclusive of read and write. Fan in, the number of functions called by a given functions within a module. Fan out, the number of other functions being called from a given function, okay, in a module. Hall stack complexity, this one is another matrix, okay, allow us to calculate more than one value, okay, means in here hall stack complexity are different metric here, you can see that. Okay, actually the hall stack complexity is very easy to do, but if you say manually do, it's very difficult. Because why? First thing is for hall stack complexity, you want to calculate, you want to identify is that the number of distinct operator in your program. How many? Let's say for example, you have using plus, minus, divide, and multiply. Okay, how many plus is used in the program? How many division operator is used in the program? How many multiply operator is used in the program? Okay, so and then you need to calculate the operands, your variable, okay, variable A, distinct operand, okay, A, how many distinct operand, how many variable you have declared for some, this is means by, okay, so, and then you need to know that the number of operators and the total number of operands. Then by using these four numbers, these four figures here, you can use to calculate the difficulties and program length, volume, program vocabulary, and also the effort used to develop this program. Okay, this is hall stack complexity. But if you using hall stack complexity, if you want to count this number of distinct operator and operands, for small program, definitely you still can use manually count. Okay, but for large program, I think not so possible. Okay, maybe you need to use the help of tools. Okay, function points. Okay, next one. Function points is the business function, the number of business function, okay, provided by your system information. Sometimes the size of the system, okay, not only can be measured by the lines of code, sometimes they can use function points to measure the size of the program. Okay, now this is the some of the metric example. Come to this one. Continue. You see, I add so many extra note inside. Okay, for you to easier understand. Okay, now continue with the metric. First one, RFC, respond for a class. What is mean by respond for a class? Means that when a class object, class is class object okay, you create the object from the class okay. So when a class object receive a message, okay, how many method is being call and execute? Understand? Okay, so this is the response for a class, RFC. Okay, so when RFC is increased, means that your test effort will be increased one. Why? Because if one message received from by a object, okay, then if there are many methods being called, means that is you have to test this one, you have to use a lot of method one. Understand? Okay? A lot of method, a lot of effort. Understand? And then the class design complexity is increased. Okay? Lack of cohesion, the second one, LCOM. Now, LCOM actually got many versions. Version 1, LCOM 1, LCOM 2, LCOM 3, and LCOM 4. But the recommended one is LCOM 4. Understand? Lack of cohesion in methods. What is this one used? Okay, actually is to calculate the number of method that does not share the instance attribute. What I mean by this one? What I mean by this one? Okay, let's say within a class, within a class, okay, so not sufficient length. Cannot. Okay. So within a class, let's say I have okay. Let's say I have you prefer to use the new method of function. Class method of class equal method, right? Okay. Method 1. Method 2. Okay. Then we have method 3. Method 4. Let's say in the class, method 1, 2, and 3, the access to the variable, this is the attribute in your class. Member, private attribute, member, SS, okay? So, this 3 access to this one access to this one. Means that your LCOM, okay, is 2. Understand? Okay? So, if okay, let's say this one also access to here, okay, this 3 also access to here, so means that your LCOM4 is 1. Understand? 1. If 1 means that your class is a good cohesion class. Understand? Okay? If LCOM equals to 1, means that your class is a good cohesion. Okay? Understand? Okay? So this is how they measure it. Okay? Why good cohesion? Because all is accessed, okay, and to achieve something. If you separate out, means that these 2, let's say for example, this one, yeah, ready? Okay. Imagine that, okay, this 3 is doing this thing, access this one. This one only access this one. There is no cohesion already. There is no cohesion. Am I right? Method 1, 2, 3, and 4. It's like separate one. Okay? And this LCOM is 4. If this one, this 3 also access this one also access this one, means that LCOM4 is 1. So means that they have a very good cohesion. For LCOM4, the value is 1, means that this class is a good cohesion class. Understand? Okay? So the LCOM, okay, is to calculate the percentage of method in the class, okay, that access to a specific attribute. And another explanation is also said that number of pairs of method which does not share the instance variable. Number of pairs of method do not share the same instance variable. 2 pairs already here. Understand? Okay? 2 pairs. So, normally they will use LCOM4, okay, for the calculation of lack of cohesion. If LCOM increase, definitely the complexity of class will be increased. Common sense, makes sense, right? Isn't it? Okay. Now, come to this one. Coupling between object. Okay. Coupling between object object class CBO. Okay. So this is one object from class A. And then this class A, do you have any connection, okay, or using others method or attribute to other class or not? If got, okay, means that there exists a coupling already. So therefore, this coupling between object is used to determine, to evaluate this one. Understand? Okay, means that a class have any connection, means either he access the method of others class or either he access the attribute other class. Okay, so we use this CBO to calculate the coupling between object class. One of the way you want to determine the CBO, you can use the CRC model. Still remember CRC? Practical 1 SDA. Is it practical 1? Practical 1 SDA, yes. Okay. CRC, requirement engineering. You got learn one, CRC. Am I right? I don't know. Okay. But I'm very sure that SDA got learn one in the practical. Yeah, CRC. Yes. The what card? The class responsible card. Remember, is it correct? Okay, yeah, class responsible card. Means that you show it what is the class there. Okay, you write down what is their responsibility, and then what is the interconnected class with them. Forgot already. CRC. In practical. In practical, yeah. I remember I got discussed with group 12381. Okay. Oh, so nice, the number 12381. Okay, now, yes. Okay, CRC. Never mind. Okay.
Medical Research Center.
This one. So many CRC already. Example, this one agile modeling. This one showing example. Got practical one. Okay, now customer order. Means that from here we know that customer has a coupling with order object already. You see that? Customer class is customer class order class is order class but customer need to access to the order. That exists a coupling already. We can use this one to determine. Understand? Okay, so just for your information okay. Now, come to here. The next one, where do I? That of inheritance trees. This one means that how many level of your inheritance, class inheritance. Let's say for example, how many level of DIT? DIT equals to compute one bigger than 4 level. Understand? Okay? This is how we count. That of inheritance tree. Okay? So count 1, 2, 3, 4. So 4 level. Okay? So means that if this one more differ, means that there is many class, okay, inherit from these classes. Okay? So more difficult to predict the class behavior. Increase design complexity. Okay, but however, best thing is you have more method to use for the lower level class. Understand? Okay. So number of children. This one very easy. Under one class. How many class is inherited from this class? Number of children. Okay. So this is the measurement. Okay. This is the measurement. Okay. So continue. We come to this one, another topic. Decompilation versus reverse engineering. What is mean by decompilation? Decompilation actually is an activity of reverse engineering. Decompilation actually is an activity of reverse engineering where we use certain tools to convert the lower level machine code back to its source code. Understand? Okay. So this is called decompilation. You can look at this one here. This is the compiler, right? Compiler, when you write the code, when we compile to machine code. However, decompiler is different, the other way around. Okay, decompile the machine code back to its source code. Understand? Decompile the machine code back to its source code. But normally, if you are lucky, then you can decompile 100%. Sometimes it's not really that precise one. Sometimes not can fully decompile one. So you can see that when you decompile, you have the disassembler, auto decompiler, and then assembly decompiler, assisted decompiler go back to your source code. So this is decompilation. This what we call this activity. However, reverse engineering is the whole thing. Everything, understand? Is the whole thing from coding back to the conceptual level. So this is reverse engineering. Decompilation definitely is reverse engineering. Why? Because you reverse engineer your code. Understand? Okay. So now look at this one. Decompiler attempts to convert an executable binary code, into a readable high-level language source code. This is very easy. You just need to understand these two terms. But as I said, if you're lucky, you can be fully decompiled. Normally, it's very difficult one. Understand? So it will not be identical to the original code. The decompiler does not include the original programmer annotation. Disassembler are the program that take executable binary of a program and create text file containing the assembly language code for the full program or part of it. When we talk about disassembler, yes, software engineering student, what is the difference between compiler and disassembler? What is the difference between compiler and assembler? Compiler is for program, right? Assembler is for just read it. It's for who? It's for what? It's for assembly. Yeah. So what is the difference between them? Compiler and assembler. Go and find out. What is the difference between? You must know as a software engineer or student. So the compilation or disassembler, a reverse engineering process, create representation system from the create a high level representation. He never say from the code. Normally definitely is from the machine code. So decompilation provide the basis for comprehension, maintenance, and new development with source code, but any high level comprehension is provided by the reader. Now this one actually just saying that decompilation definitely is a reverse engineering activity or reverse engineering. So now we come to this one, another topic. Data reverse engineering. This is how we go. This topic is to discuss on how the process to reverse engineer our data. Means the database So what is mean by this process defined as the use of structured techniques to reconstitute the data asset of an existing system. The data asset maybe is in your data file or maybe it's in your database. So the two vital aspect of DRE, DRE stands for data reverse engineering, is to recover the data asset. When we talk about asset, normally it's valuable, so we call it as an asset. Reconstitute the recover data asset to make them more useful. So these are the two vital aspects of DRE process. Continue. The purpose, acquire knowledge. Because why? Very simple one. Reverse engineering is to understand the existing system. Data reverse engineering, we need to know about the data, the collection, the models, and the information for the software. It can act as a throughout the data reverse engineering. We can find the tentative requirement for the new system. Understand? So these are the two of the purpose. Continue for documentation purpose. Okay, improve the documentation for the existing system. Integration, facilitate integration of application. Why? Because you can just from the data you can have the logical model. Understand? Okay. So this logical model can act. Okay, is a prerequisite for the integration between the parts of the system. Okay. Another purpose, so many purposes. Data administration, okay, allow for better manipulation or management of data. Okay, conversion to migrate data. Software assessment, evaluation of the, when we reverse engineer, we can evaluate the criteria for the software product. Okay, because this one we used to assess the the DBMS Quality assessment definitely lah. Okay, we see that okay when we doing the data reverse engineering, we will know that okay what are the flaws of the design. Okay, in the data structure or in the data model, or even when you start reverse engineer the existing data, you find that okay how come they create the data in this design how come they design the table in this way okay, they may exist some weakness or limitation understand? So for you to assess the quality. For another last purpose is for the component reuse. Okay, some data okay you may be able to reuse it back. Okay, maybe even though the database you tidy it up, okay, maybe you can reuse it back. Okay. DRE consists of two processes: extraction and conceptualization. Extraction actually is consists of those activities you start from study the physical database understand? Then you come out with the basic what we call database schema or model, understand? Then from there you start with the conceptualization. You continue to maybe normalize, okay, maybe refine the database, okay, into its high level. So this is called the data conceptualization. Now, and then one thing is I changed the order of the slide. This slide should be the last slide, okay. So but I changed here, why? Because I want you to have an idea of this data reverse engineering first, okay. Look at the diagram here before we go to each process, okay. Now this is the diagram. It's okay. You want to leave it in the last slide, or you want to follow me to put in this slide. It's okay one. Doesn't matter one. Okay. So, but I think I put here because using diagram is easier. You can see that this is data extraction. Data extraction, and then from here, you may have your data conceptualization. Okay. Data extraction start with study the physical database. Okay, and study the DDL database data definition language. Okay, and then the programs and the data. Why you need to study the program? Okay, you can see why you want to study the program later. Okay, you study the existing database. Okay, understand their DDL understand the DDL. Why you understand DDL? Because DDL is the data definition language for you to create the modify the structure of the tables on the data Okay, so from there, okay, then you analyze it. Understand? This is the input. Analyze it, okay, and then at the same time, maybe you also can analyze the program. Why you want to analyze the program? Because by analyzing the program, you may find maybe others data is required one. You get me? Okay. So and then with the data here, this is a schema, right? This is the data. Okay. You also perform the analysis. Then from all this analysis, you may come out with the basic schema of the existing system, of the existing database. Understand? So and then maybe okay, you come up with this one. Okay, that schema integration actually is sometimes when certain system okay, the data source may not be only one data source. He may be separate into different distributed data source. Okay, so is it the distributed system is talking about this one? Distributed data source. group 1? Joyen. Yeah, is it your distributed system is also talking about distributed database also?
System yes, database no.
Oh, system yeah, doesn't matter. Okay, because some system okay, you not necessary to access only one database okay, maybe access database in different location, and this database in different location may have different schema different data structure understand? Okay, so in this case, schema integration means you have to check that okay, is it connected with others database? Okay, then from there you may retrieve the portion view of the data so that you can know that okay, come up with the exact okay initial schema of the existing database that this program is using. You get me? Okay, so this is called schema integration. It's not like really integrate. Okay, you want to check that okay, this database, okay, this program is really maybe is integrate with others database, okay, or not, and then this others database may have different structure one. So you need to analyze that one also, so that you can come up with the schema that represent that is going to be used, that is using by this system or for the existing database. Understand? Then from here, you come to here already, right? Then you prepare the schema. Okay, keep on refining, tidy up. Okay, and then schema and translation. Okay, so in this case, you may need to revert back to those more English-like schema what I said is okay. So then you come up with the conceptual, logical, physical schema. And then schema de-optimization, very funny. Why we want to schema de-optimize? Because sometimes an optimized schema is very difficult to understand one. Because you go through when you optimize the schema, he may go through a lot of different process. Maybe he separate the field for easy access whatever thing. So in this case, it's very difficult to understand. So we de-optimize it the schema, make it okay more easier to understand from the perspective of data. Understand? So and then now you proceed okay to derive the conceptual schema, very high level already, and then normalization. I believe you know what is normalization already okay, normalize, perform normalization on the conceptual schema. Then this is the output. This is the output of DRE. Understand? Now we can look at the description for each of the process. Data extraction obtains the current data structure from the DDL. Okay, this phase recover the whole data management system schema. Okay, from the DDL recover the whole schema can be come to here Okay, understand? Okay, this one So for the data conceptualization, I haven't yet. Okay, then we start with this process. Okay, DMS, DDL text analysis, analyze the DDL. Okay, as I said just now. Okay, so to know that okay the structure, some of the structure of this database, program analysis examine the source code. Okay, for additional structure. DDL analysis, program analysis. Understand? Okay, and then we come to data analysis. Analyze files, database, anything that regarding to the data. Okay, and then identify the structure, the name, the type. Okay, and then maybe you need to understand that whether is it possible that this field is a primary key or a composite key or a foreign key. Understand? Okay, you have to know that. So schema integration, as I said, when your program is integrated with more than one data source, okay, maybe different data sources. Sometimes when the data is getting from data source to generate complete information. So you have to check on the link data source. So okay, to observe that okay exactly what are the data is still required okay in this program. Okay, so from there you know okay what are the structure of the data. So basic conceptualization. Okay, this one you generate a conceptual schema that describe the semantic of the existing data structure. Okay, so now making the schema ready schema untranslation and schema optimization. Look at this one. Come to here already. Okay? Schema untranslation, schema the optimization. Schema untranslation, technical translation. Once you get that, normally it's very technical one. Understand? So maybe it's using lots of technical jargon or what's there. So in this case, you need to convert this technical to what they call to a more conceptual, as I said, more English-like lah. Okay, easy to understand one. Because sometimes you use technical maybe based on different database or different company the jargon they use is different one, so it's very difficult to understand. So you try to untranslate this one into a more high-level conceptual or more general, okay, word or terms. Understand? Okay. So schema, the optimization, an optimized schema is generally more difficult to understand. So you try to denormalize it. Okay. No, not denormalize. De-optimize it. Okay. So now after that, conceptual normalization. Okay, this is you have to tidy up lah. Okay, for example, replace entity type with entity relationship type, replace some entity by attribute, make the relationship explicitly, standardize the name. Okay, so keep on tidying up. So therefore, you come up with the conceptual normalization schema. Okay, then reverse engineering tools. What is reverse engineering tools? Okay. This is the basic structure of a reverse engineering tools. Okay, so this is the product. Then come to here, semantic analyzer. Okay, analyze the meaning, the character. Okay, and then store into the information base repository, view composer, and then come up with the new view of product. This is the basic structure of your reverse engineering tools. Okay, and this is the example of reverse. Don't go and memorize this one. Okay, so reverse engineering tools example, and then this is the references, and this is the end of our topic. Okay, so we take 10 minutes break. We take 10 minutes break. We cover a bit on the chapter 8. I think we cover how many slides? Run on old processor. Okay, much more slower, which is support team is completely relying on the experience and the knowledge, not from the documentation. Okay, these are the features. Now, then what are the solutions for the legacy system? What are the solutions for the legacy system? How come my mic, the cable is becoming shorter and shorter? Okay, so freeze. Freeze means that not to carry out further works on the LIS means legacy information system. Okay, outsource the maintenance task, support task. Okay, outsource from others people to help you to support it. Okay, carry on maintenance by yourself. Okay, discard and redevelop, throw away the old system, redevelop it. Okay, from scratch. Okay, in the new hardware and new platform. Wrap, this one, I guess some of the group we already encountered this one already. Wrap, okay, surround the LIS with a new layer of software by hiding their complexity, interfaces, and so on. Okay, migrate the system into a new modern platform. This is your assignment topic. Okay. Okay. So this is the solution for legacy system. Okay. So now done already. I have a quiz for you. Chapter 7 Okay. I almost forgot already. I my library. I remember this one. Software engineering. Okay, so live session, classic lah, master repeat or classic ah? Classic lah, okay. Classic and continue. This is the code. Please enter. This is the intention of releasing stress or dissatisfactory. Start already ah? Okay. Why my screen cannot show ah? Only 39 participants lah. How come? Got so few man my class here. Okay. Code is here. how many principles? Rework strategy. This is chapter 6. Rework strategy applies how many principles? Section group 6. Not here. Group 6. Hey, yes, class rep. Class rep is not. It's very busy. Yes. Section. Where is section? Is section here? Yes. Section. What are the principles used in rework strategy? Yeah, there are 3 things in group 6. Yes. Principle of abstraction, alteration, and refinement. However, replace only apply abstraction and refinement. Rewrite apply alteration. Okay, so these are the principal concern. Still got lah? Is it still got? Don't have. Okay, that's it for our quiz. Any question, class? No. Okay, no. Then I'm very happy. Okay, so this is the first time. Okay, when student there is no questions. Okay, and next week is the midterm. Okay, so. Listen carefully. I only speak one time. Okay. Loss, CBS, stage model. Okay.